Okay, this is another kind of problem that usually uh, pose a major challenge for students because of the way it's worded and the diagram that you draw, and a lot of students, they just focus on numbers and they don't really understand the context. So I want to make sure that you read this question very carefully and then come back to this video, and I'm going to explain to you more. Okay. So let's go ahead and draw this diagram and get a sense of the setting right here. So we have two cars, car A and car B, and they are separated away from each other. So we have car A and car B. Okay, so let's go ahead and draw a line right here. So car A, it's 100 kilometers away from car B. Okay, and car A is cruising west for 35 miles per hour. And the car B, it's going up north for 25 kilometers per hour. Okay, and then we ask, well, at some point in time they are going to have a distance between them, and we are asked how fast is the distance between the cars changing at 7 p.m. So it starts at 3 p.m. it ends at 7 p.m. so we are talking about 4 hours later. Okay, 4 hours of time. So now let's draw another diagram, and this is the challenge right here. So we can get that they are going to be something. They're going to be separated with like a triangle like this. Let's put down some numbers. Okay. Now a lot of people, if they are just putting numbers down quickly and they're not thinking clearly, they're going to put down 25 here. And if you put 25 here, that it's going to be incorrect, because this is distance and 25 kilometers per hour is speed. So you have to use the speed, use the time to find out how many kilometers are there from the original point to the end point after 4 hours. So distance over time, it's equal to speed. So if you want to find distance, you multiply speed with time. So 25 times 4, this is 100 kilometers. Okay. And what about here? What about this distance? Okay, this is B, this is A. Now originally it was separated by 100 kilometers. But after 4 hours, car A has traveled some distance. So how many kilometers has A traveled throughout the 4 hours? So it's basically 4 times 35, which is 140. So it has traveled 140 kilometers plus the 100 kilometers that's originally there. So the total distance is going to be 240 kilometers. Okay, now what is the distance right here between A and B right now at this moment? Well, we can use Pythagorean theorem to calculate it. So it's going to be 240 square plus 100 square. It's equal to the hypotenuse square. So it is going to be 260. Okay, it happens to be a very nice number, 260 kilometers. All right. Now, what about these numbers? So let's write it down, label them. So we're saying dA and dt is 25 kilometers per hour, and oh no, hold on, this is dB dt. dA dt right here is 35 kilometers per hour. All right. So let's say this is x. So we wonder, what is the rate of change for x as these two cars are moving in two separate directions? So we are trying to find out what dx dt is. Okay, so let's go ahead and set up an equation to relate these three things together. So it is going to be a squared plus b squared, it's equal to x squared, Pythagorean theorem, Now, since these two cars are still traveling, so A is not a constant, B is not a constant, and X is definitely not a constant. So we don't have anything to change here for this equation. So what we will do is to go ahead and differentiate this equation. Now, if you have seen the previous videos, so this should be very familiar to you. Okay, and I'm gonna go ahead and do this a little bit faster because you should be very equipped after watching my previous videos. So it's going to be 2a dA dt plus 2b dB dt. Okay, and this is going to be 2x dx dt. Again, these three things, they are showing up here because a, b, and x, they are not just a variable, they are actually functions in terms of time, in terms of t. So we have to use chain rule, and since we don't see t here, so we call this implicit differentiation. Now, do we have numbers given? Do we have a given? Yes, we have a. We have dA dt, don't we? Yes, we have that. To b is given right here is 100. dB dt, it's also given. X, we calculated it, right? X calculated, it's 260. And all we need to solve is dx dt, which is exactly what we're trying to find out. So let's go ahead and substitute some numbers in here. And dA dt is 35 plus 2 times b is 100, and dB dt is 25. And 2 times 260, and dx dt. So you can go ahead and use a calculator to calculate this. 2 times 240 times 35 plus 2 times 100 times 25. And then you go ahead and divide it by 2 times 260. Make sure you use parentheses. And what we find out here is that dx dt, it's equal to 41.9 kilometers per hour. Okay, so as these two cars are traveling in two different directions, the distance between A and B, it is changing by 41.9 kilometers per hour. So this is a kind of question where you have to be very careful what you're drawing and what you are labeling. You cannot just label a number, you have to understand unit. And if the unit, it's not what you're drawing, like this is distance, but you are putting in speed in here, this is not going to give you a correct answer. So make sure the meaning of these numbers and draw your diagram, label your diagram correctly.